Welcome to class number 88. Last time class, see, this is a question solved. Uniformly varying load. This time, if you remember, if you have gone through that one, the SF was found to be 0 somewhere between these 2 points, somewhere here. So you have to locate that point. We took x from this side so that when you look this side, you get triangle. At that time only I told, next class question, x you have to take from that side. So this is today's class question. And remember, this question is practice question. So I wrote everything in the board because first of all, this type of loading already we covered plenty of questions earlier. So actually I can give question and only answer, nothing else. But at least for those who find difficulty, let them at least go through something to understand. Okay, start. First question here. In words if you want, simply support beam of span 10 meter loaded by uniformly varying load with intensity 0 at right end, maximum of 60 kN per meter at left end with the 2-point load at 2 meters from here 150, at 3 meters from right end 200 kN. Draw SFD BMD. First, reaction calculation. Write one more sketch here, right here, calculation of reactions. Let VA and VB be the reactions. Okay, I will tell here only minus VB into 10 plus 150 into 2, 200 into 7 plus full load half into 10 into 60 is the total load into 1 by 3 of 10 equal to 0. See, last time question, not 1 by 3, 2 by 3 from here. This time 1 by 3. This also I told last class. Okay, you get VB, sigma V0, you get VA, entered both the reactions here. I entered both the values here. Okay, now next. So VA, VB both are over. First, draw the shear force diagram. See, if you want to show the calculation, see, shear force at A plus 380, shear force at C just to left plus 380 minus this much load. How much? 60 plus 48 divided by 2 into 2. Oh, forgot one thing. After finding the reactions, before coming here for SFD BMD, you should write one more thing. For SFD and BMD, you need intensity here and intensity here. You take the point as C and D, light line mark here, intensity at C, WC, WD, then WC equal to 60 by 10 into 8, WD equal to 60 by 10 into 3. Get those values and enter here. Okay, now, shear force, just to right of this one. Whatever you got just now, minus 150. Shear force, just to left of D. Whatever you got just to right of C, minus this much load. Just to right, minus 200. Lastly, find shear force at B, subtract this load. Values you can see here. Or, take your calculator, directly you can draw. Go up by 380. 380. Then, from here to here, come down by this much load. 60 plus 48 divided by 2 into 2, it will come down to 272. Suddenly come down by 150, 122. Again come down parabolically by 48 plus 18 divided by 2 into 5, it will come to minus 43. Down by 200, minus 243. Again down by half into 3 into 18, you will reach 270. See, last time intensity is 0 here, maximum here, your parabolic, see, now A to C, C to D, D to B, parabola of second degree, you should write. Last time, see what happened? See, if I draw shear force for last time, after here slope is 0, intensity is 0, and as you go here, intensity increases, so it was this way. Slope will keep on increasing, but this time, not that way, reverse. See, as you go this way, slope decreases. So here maximum slope will come here. And as you come here, slope will reduce. Okay. If I make too much correction, then everything will go. Once again, I have to write now. See, this way. Slope a little more actually, because same slope should be there at both ends. That's why I don't want corrections all. Okay, now, this way slope, here also this way. And one more thing, see here. If I draw tangent here and tangent here, the slope should be how much? 48. Why? Slope of SFD is intensity of load. Here also, if you draw tangent at the end portion and starting point here, slope should be 18. Okay, now come to BM calculation. Start. you should write BM at A, 0, BM at B, 0, BM at C. Look this side. Trapezium will come. Okay. Plus 380 into 2 minus moment of this load. 60 plus 48 divided by 2. 2 is not this 2. Divided by standard 2 into 2 is the total load into, from here to here is 48 plus twice of 60 divided by 48 plus 60 into 2 by 3. Better look right side. You write right side only. Those who are serious and can understand, do this way. Or look this side. 270 into 8 positive minus moment of this full load. Half into 8 into 48 into 1/3 of 8. Also minus 200 into 5. You will get plus 648. BM here. Look this side. Plus 270 into 3 minus half into 3 into 18 into 1/3 of 3. You get 783. A to C, parabola of third degree. C to D also parabola of third degree. D to B, same thing. Now, here slope is maximum, why 380. Here slope is lesser, 270. And at this point, this side curve, if you do tangent, slope should be 272. If you do tangent this side, it should be little flat. Slope is 122. Here also, this side slope is how much? 243. This side 43. Here is space problem. I cannot draw very accurately. In the notes, I will write all those correctly. I will be very careful there. Okay, now, and also, lastly, BM at A over, B over, C over, D over. Now, oh sorry, forgotten one thing. After drawing shear force diagram, forgotten means now I will remember. Before starting BMD or BM calculation, first location of the point where SF is 0. You should do this one. Then only what? Then only come to bending moment calculation. Okay, start. Location of the point where SF is 0. Let it be at X from B. Why B? Because if you look this side, triangle you are going to get. Look left side, trapezium will come. Answer will come. It came earlier, but not required. Okay, now, we need intensity at X point here. See, this is the point. This is C. This is D. After this point, it is there. After this point, this is D. So, here intensity required. 60 by 10 into X. I wrote here. 6X is the intensity. Now, shear force 0 here. Look this side. Right side you are seeing, right up is negative, minus 270 plus this much load, half into X into 6X is and also plus 200 equal to 0, you will get X value. See, later after the course is almost over, when traditional solution is over, I will go for shortcuts, very useful for objective type questions. You will wonder at that time how many shortcuts, how many tricks I will give. Now I will do one thing now. Suppose I want to get X. If I go to an interview, someone will ask me, tell me where shear force is 0, you get the value. See what I will do. I will tell you what I will do. I will not see first of all here. I will not see anything here. 270 minus 200 into 2 divided by rate is 6, root, answer 4.8305 meter. They will ask, how you got it? You asked where, I told the answer. How you got it means I will explain to you. So these are all you learn later, not now. So for that matter, those shortcuts I am planning to write or take classes for other chapters of not only strength of materials, engineering mechanics, structures, RCC, etc. Not now, later stages. Okay, now get X value, enter here. Then substitute that X value, get intensity, 6 into X, you get the intensity here. Now, BM at A 0, B 0, C and D I already explained. Now lastly, BM at X. Look this side. Plus 270 into 4.8305 minus half into 4.8305 into 28.983 into this triangle, 1/3 of 4.8305 and also minus 200 into this distance. I wrote everything here. So that important point, that's why I wrote everything. Okay, now, so BM here, it will reach the peak value here and come down. Highest value is here, maximum BM. Draw the BMD, thoroughly practice, understand, and gain more and more knowledge. See, all these questions, someone will ask, why so many questions? This is how you get the grip. Once you get the grip, sorry, you can play with the subject then. See, I will tell you now, next class, 89, what I will do. 89 class, what I will do is, I will once again take a problem of this type. But there, I will see that SF will cross the baseline under the point load. So that X will not be there. See, that means this part is not there. Amount of work is reduced. Then I will take one more question next time only. Same this type. I will put one more load here. And again SF will cross the baseline under the load. So for next class, both the questions, amount of work is lesser. That locating the point and this part is not there. Very fast you can do it. So I will do it in front of you briefly. I will put the two questions here. Write the first question here. Write the second question here. Draw the diagram, or I may draw the diagram earlier also to save time. Because why? Otherwise, sometime adjusting the curve takes some time. Or I will draw in front of you only, no problem. In front of you only I will draw. I will draw calculation. Briefly I will tell. You note down and solve. First of all, if the SFD crosses a baseline at a known point, amount of work is lesser, people will be happy actually. Okay, now we will meet in class number 89. That is for those once again for two practice questions. Okay, thank you.